The mass of one mole of a compound is the sum of all the masses of the moles of its component elements. So what this simply means that if we have a compound, all the elements that are involved in the compound, the 1 mole of that compound it comprises of all the elements, the masses of 1 mole of each of those elements that are involved. So when you join them together, some of those components will give you what? The mass of 1 mole of that compound. So based on that, we can also use it to calculate. It means that the percentage by mass of each of the component elements of any compound can be calculated. You knowing that knowing the idea that having this idea that each of them are the sum of um, various components. So in this case now, just like what we have as the definition there, let's say we have calcium chloride. Let's say we have calcium chloride. Now, calcium chloride, we know that calcium is 40 plus, based on, let's say that sum, the component element in calcium is what? Calcium chloride is calcium and chlorine. Now, in this case, in this chlorine, we have it to be 35.5. And then in this place, we have it to be 2 chlorines. So when 2 multiply this, we have 71, and this other 40 will give us what? 1 gram. That is the mass. So in this case, we'll be able to find out that 1 mole, so that a mass of 1 mole of a compound is the sum of what? The masses of all the moles of its component elements. Now, the moles of this, we'll use it now to gather or information on what the compound, the mass of 1 mole of calcium chloride. So in the same way, if this thing is possible, it also means that we can also calculate percentage by mass of each of the component elements that we have there. So that is what we're going to do now. We'll have an example here. The example says calculate the percentage by mass of each of the component elements of copper 2 tetraoxosulfate 6. That is what we are going to look at it. Having said that, we know that copper 2 in this copper 2 tetraoxosulfate, we have copper to be 64, sulfur to be 32, and then oxygen, which is 4 there, bracket 16. So what we have here, we should be plus 32 plus this, that will give us 64. So when we sum it up, if we sum up everything we have, let's see, we have 4 and 2. That means we have 0 here, carry 1. Then here we have 6, 12. Plus this, we have 5 plus 1, we have these grams. That is what we have. That is what we have there. So now with this, the question says we should calculate the masses, the percentage by mass of each of these each components. So we'll start by working with copper. Copper here, we have that copper percentage by mass of what? Copper. We will say is that copper is 64, and the mass of the compound is what? 160. Then we multiply by what? 100. So when we multiply by 100, what we will have there will be this will cancel out, and in fact everything will give us 40%. 40% of what? copper is there present in what? Copper 2 tetraoxo sulfate 6. So the next one we're going to do here is that we are going to look for the next one, which is sulfur. In the case of the sulfur, we have percentage by mass of what? Sulfur. That is, we have in sulfur here we have 32 over 160 times 100 over 1. That will give us so when we do this, we have 20%. We have 20%. That is percentage by mass of sulfur here is what? 20%. The next one we have here will be the oxygen. Now, in the case of percentage by mass of oxygen, in this case, oxygen is what? 64. So what we have here, 64 over what? 160 times 100 over 1. That will give us the same 40% like that of copper. So in all these things, you can find out that what we have been able to do here is to find out each of their various percentage by mass. And that this percentage by mass can also be used in in calculating, for example, when you want to calculate something like empirical formula. This is one of the things we use in doing some of this empirical formula. So, but then here we want to limit it to this, but perhaps in the previous classes, I'll be able to look into the other areas how we can use this thing to find out the empirical formula of any compound. Thank you so much, and if you have not subscribed, I will encourage you to do so, and then like, share. Let's read your comments. Let's know how you feel about the class today. Thank you so much.